Substance. In our daily life, there are many instances when we notice a substance being separate from a mixture of material. Tea leaves are separate from the liquid with a strainer while preparing tea. Grains is separate from stalks while harvesting milk or curd is churned to separate the butter. We gin the cotton to separate its seed from the fiber. Perhaps you might have eaten salted daily poha if you found that it had chilies in it. You may have carefully taken them out before eating. Suppose you are given a basket containing mangoes and guava and asked to separate them. What would you do? Pick out one kind and place them in separate container, right? Seems easy, but what if the material we want to separate are much smaller? The mangoes agave. Imagine you are given a glass of sand with the salt mixed in. It is impossible even to think of separating salt from this mixtures by the picking out a grain of sand by sand. But they would be need to separate substance like this at all is what Paheli want to know. In column 1 or 3.1 are given few process of separation. The purpose of separation and the way separated components are used is mentioned in column 2 and 3 respectively. However, the information given column 2 and 3 jumped up. Can you match each? Why do we separate substance? Separation process. Separate stone for rice. Purpose for which we do separation. To separate two different but useful component. What do we do with separate component? We throw away the solid component. Churning milk to obtain butter. To remove non-useful component. We throw away the impurities. Separate tea leaves. To remove impurities or harmful component. We use both the components process with its purpose and they with separated component are used. We see that before we use a substance we need to separate harmful or non-useful substance that may be mixed with it. Sometimes we separate even useful component if we need to use them separately. The substance to be separated may be particles of different size or materials. These may be in any three states of matter: solid, liquid or gas. How do we separate substance mixed together if they have so many different properties? Method of separation. We will discuss some simple method of separating substance that are mixed together. You may come across some of these methods being used in day-to-day activities. Hand picking. Bring a packet of food grains purchased from a shop to the classroom. Now spread the grains on a sheet of paper. Do you find only one kind of grain on the sheet of paper? Are three pieces of stone, husk, broken grain and particles of any other grain in it. Now remove with your hand the piece of stone, husk and other grains from it. This method of hand picking can be used for separating slightly larger side impurities like the piece of dirt, stone and husk from wheat, rice or pulse. The quantity of such impurities is usually not very large. In such situations, we find that hand picking is a convenient method of separating substance. Threshing. You must have seen bundles of wheat or paddy stalks laying in the field after harvesting. The crop stalks are dried in the sun before the grain is separated from them. Each stalk has many grain seed attached to it. Imagine the number of grain seed in hundreds of bundles of stalk laying in the field. How does the farmer separate grain seed from those bundle of stalks? How one may pluck mangoes or guava from the trees, but grain seed are much smaller than mangoes or guavas, so plucking them from their stalk would be possible. How does one separate grain seed from their stalks? The process that is used to separate grain from stalk, etc. Threshing. In the process, the stalks are beaten to free the grain seed. Sometimes threshing is done with the help of bulls. Machines are also used to thresh large quantity of grain. Winnowing. Make a mixture of dry sand with sandwashed and powdered dry leaves. Keep The mixtures on a plate or newspaper. Look at the mixtures carefully. Can the two different components be made out easily? Are the size or particle of the two components similar? Would it be possible to separate the component by hand picking? Now take your mixtures to be an open ground and stand on raised platform. Put the mixture in a plate or sheet of paper. Hold the plate or the sheet of paper containing the mixtures at your shoulder height till it slightly showed the mixture slides out slowly. What happens? Do both the components sand and sand dust or powder leaves fall at the same place? Is there a component that blows away? Did the wind manage to separate two components? This method of separating component of mixture is called the winnowing. Winnowing is used to separate heavier and lighter component of mixtures by wind or by blowing air. This method is commonly used to separate lighter husk particle from heavier seed of grain. The husk particles are carried away by wind. The seed of grain gets separated and from heap up near the platform for winnowing. The separate husk is used for many purposes such as the fodder for cattle. Saving. Sometimes we may wish to prepare a dish with flour. We need to remove impurities and bran that may be present in it. What do? We use a sieve and pour the flour into it. Saving flows the fine flour particles to pass through the holes of the sieves, while the bigger impurities remain on the sieves. In a flour mill, impurities like husk and stone are removed from wheat before grinding. Usually a bag full of wheat is poured on the slanting sleeve. The sleeve removes spice of stone, stalk and husk that may still remain with heat after threshing and winnowing. You may have also noticed similar sieves being used at a construction site to separate pebbles and stone from sand. Bring a sieve and small quantities flour from home to the class sieve. Flour to separate any impurities in it. Now make a fine powder of chalk pieces and mix in with the flour. Can we separate the flour and the powdered chalk by sieving? Sieving is used when a component of a mixture have different size, sedimentations, decantations, or filtration. Sometimes it may not be possible separate component of a mixtures by the winnowing and hand picking. For example, there may be lighter impurities like dust or soil particle in rice or pulse. How are such impurities separate from rice or pulse before cooking? Rice or pulse are usually washed before cooking. When you add water, these impurities like dust and particles get separated. These impurities go into water. Now what will be sink to the bottom of the vessel? Rice or dust. Why have you seen that a vessel is still to your outer dirty water? When you have a component in a mixed settle after water is added to, in this process is called sedimentations. When the water along with the dust is removed, the process is called the decantations. Let us find a few other mixtures that can be separated through the sedimentations and decantation. The same principle is used for the separating mixtures of two liquids that do not mix with each other. For example, oil and water from their mixtures can be separated by this process of a mixtures. If a mixture such liquid is allowed to stand for some time, they form two separate layers. The component that from the top layer can then be separated by decantations. Let us again consider a mixture of solid and liquid after preparing tea. What do you to do? Remove the tea leaves. Usually we use strainer to remove tea leaves. Try decantation. It helps a little, but do you still get a few leaves in your tea? Now pour the tea through it up. Strainer. Did all the tea leaves remain in the strainer? This process is called filtration. Which method of separating tea leaves from separate tea is better, decantations or filtration? Let us now consider the example of water that we use to all of us at all time. Get safe and water to drink. To drink, sometimes water supply through taps may be muddy. The waters collect from ponds or rivers may also be muddy, especially after rain. Let us stream if we can use some method of separations to remove insoluble impurities like soil from the water. Activity 5. Collect some muddy water from a pond or a river. If it not available, uh, mix some soil to water in glass. Let it stand for half an hour. Observe the water carefully and note your observation. Does some soil settle at the bottom of water? Why? What will you call this process? Now slightly tilt the glass without disturbing the water. Let the waters from the top flow into another glass. What will be you call this process? Is the water in the second glass still muddy or brown in color? Now filter. Did the tea strainer work? Let us try filtering the water through a piece of cloth. In a piece of cloth, small holes of pore remain in between the woven threads. These pores in a cloth can be used as a filter. In the water is still muddy, impurities can be separated by a filter that has even smaller pores. A filter paper is one such filter that has very fine pores in it. 3.0 show the steps involved in using filter paper. A filter paper folded in the form of cone is fixed on the funnel. That mixture is then poured on the filter paper. Solid particles in the mixtures do not pass through and they remain on the filter. Fruit and vegetable juice are usually filtered before drinking to separate the seed and solid particles of pulp. The method of filtration is also used in the process of preparing cottage cheese paneer in our home. You might have seen that for making paneer, a few drops of lemon juice are added to milk. Is it? Well, this gives a mixture of particles of solid paneer and liquid. The paneer is separated by filtering the mixtures through a fine cloth or strainer. Evaporation and 2 spoons of salt to water in another beaker. Try it will do you. See any changes in the color of water? Can you see any salt in the beaker after stirring? Heat a beaker containing the salt water. Let the water boil away what is left in the beaker. In this activity, we use the process of evaporation to separate a mixtures of water and salt. The process of conversion of water into its vapor is called evaporation. The process of evaporation takes place continuously where water is present. Where do you think salt comes from? See, water contains many salt mixed in it. One of these salt is the common salt, and when water is allowed to stand in shallow pits, water gets heated by sunlight and slowly turns into water's vapor. Through evaporations a few days, the water evaporates completely, leaving behind the soil salt. Common salt is then obtained from the mixtures of salt by the further purifications. Use of more than one method of separation. We have studied some method for separation of substance from their mixtures. Often one method is not sufficient to separate the different substances present in a mixture. In such situations, we need to use more than one of these methods. Activity 7. Take a mixture of sand and salt. How we will separate these? We already saw the hand picking would not be particles method for separating these. Keep these mixtures in a beaker and add some water to it. Leave the beaker aside for some time. Do you see the sand setting down at the bottom? The sand can be separated by the decantations or filtrations. What does the decantation liquid contain? Do you think this what contains the salt which was there in the mixtures at the beginning? Now we need to separate salt and water from the decanted liquid. Transfer this liquid is a kettle and close its lid. Heat and kettle for some time. Do you notice steam coming out from the spout of the kettle? Take a metal plate with some ice or it. Hold the plate just above the spot of the kettle as shown in figure. What do you observe? Let all the waters in the kettle boil off. When the steams connect with the metal plate cooled with ice. It condensation and from liquid water. The water drops that you observe falling from the plate were due to condensations of steam. The process of conversion of water vapor into its liquid form it called condensations. Did you ever see water drops condensations under a plate that has been used to cover a vessels containing? Did you ever see water drops condensed under a plate that has been used to cover a vessel containing milk that has just been boiled? After all the water has evaporated, what is left behind in the kettle? We have thus separated salt, sand and water using process of decantations, filtrations, evaporation, condensations. Paheli faced a problem while recovering salt mixed with sand. She has mixed a packet of salt in a small amount of sand. She then tried to method suggested in activity 7 to recover the salt. She found, however, that she could recover only a small part of the salt. She found, however, that she could recover only a small part of the salt that she had taken. What could have gone wrong? Can you water dissolve any amount of substance? In chapter 2, we found that many substances dissolve in water and form a solution. We say that these substances are soluble in water. What will be happen if we go on adding more and more these substances to a fixed quantity of water? Activities 8. You will need a breaker, a small pan, a spoon, salt of water. Pour half a cup of water in the beaker. Add a 1 teaspoon of salt and stir it well until the salt dissolve completely. Again add a teaspoon of salt and stir. Well, go on adding salt 1 teaspoon at one time. Stir. After adding a few spoons of salt, do you find that some salt remain undissolved and settle at the bottom of the beaker? If yes, this means that no more salt can be dissolved in the amount of water we have taken. The solution is now shade to be saturated. Here is a hint as to what might have gone wrong when Paheli tried to recover large quantity of salt mixed with sand. Perhaps the quantity of salt was much more than that required to form a saturated solution. The undissolved salt would have remained mixed with the sand and could not be recovered. She could solve her problem by using larger quantity of water. Suppose she did not have sufficient quantity of water to dissolve all the salt in the mixtures. Is there some way that water could be made to dissolve more salt before the solution get saturated? Let us try and help Paheli out. Take some water in a beaker and mix salt in it until it cannot dissolve any more salt. This will give you saturated solutions of salt in water. Now add a small quantities would have remained mixed with the sand and could not be recovered. She could solve her problem by using large quantity of water. Suppose she did not have sufficient quantity of water to dissolve all the salt in the mixtures. Is there some way that water could be made to dissolve more salt before the solution gets saturated? Let's try and help Paheli out. Activity 9. Take some water in a beaker and mix salt in it until it cannot dissolve any more salt. This will give you saturated solution of salt in water. Now add a small quantities of salt to this saturated solution and heat it. What do you find? What happened to the undissolved salt in the bottom of of the beaker. Does it dissolve now? If yes, yes, can some more salt be dissolved in these solutions by heating it? Let this hot solutions cool. Does the salt appear to settle at the bottom of the beaker again? The activity suggests that losses quantity of salt can be dissolved in water on heating process. Does the water dissolve equals amount of different soluble substance? Let us find out. Activities 10. Take 2 glasses of pour half a cup of water in each of them. Add a teaspoon. Take 2 glasses and pour half a cup of water in each of them. Add teaspoon of salt, 1 glass still salt. Dissolve one, adding salt 1 teaspoon at a time till the solution saturated. Record the number of spoons of salt that dissolve in the water in table 3.2. Now repeats the same activities with sugar. Repeat this with some other substance that are troubles in water. What do you notice from table 3.2? You find that water dissolve in different substance in different amount. Table 3.2 substance, number of spoons, salt, sugar. We have discussed a few methods of separating substance. Some of the method of separation presented in the chapter are also used in science laboratories. We also learned that a solution is prepared by dissolving a substance in a liquid. A solution said to be saturated if it cannot dissolve more than the substance in it. Thank you so for watching.